9.2 and 9.3, and we're going to be talking about area, volume, and capacity. And this is just a little kind of gets you warmed up that I took from the book. It says, are you feeling a bit crowded in? Although there are more people in the east coast of the United States than there are bears, there are places in the Northwest where bears outnumber humans. The most densely populated state is New Jersey, averaging 1,171.1 people per square mile. The least densely populated state is Alaska, averaging 1.2 persons per square mile. A square mile is one way of measuring the area of a state. A state's area is the region within its boundaries. Its population density is its population divided by its area. In this section, we discuss methods for measuring both area and volume. And this is actually, if we were talking, we're kind of we're in our little hot air balloon, we're looking at all different types of mathematics. And calculating area and volume, geometric operations, is an area of mathematics, and it's not actually trivial when you don't have just a rectangular shape, And you have to use, but we use this concept of squares or rectangles to calculate area. And in calculus, if the shape is not a rectangle, what you do is you fill the shape with infinitely many little bitty rectangles, and you calculate their areas and you add them up. That's a technique called integration, and there's mathematical operations that you can use to find area under non-square or non-rectangular shapes. So it's kind of an interesting concept. We have units of measurement in the English system. We have the square foot. Now, last time we learned that about a conversion, so I want to kind of explain to you why 1 square foot is 144 square inches. If you have 1 foot squared and you want to convert that to inches, you need to cancel feet twice, because you've got foot squared, which means feet times feet. And so you've got inches here and inches here. Does that make sense? So your unit fraction or unit multiplier, you actually have 2 of them. So there's 12 inches in 1 foot, 12 inches in 1 foot. So that's how they get the 144 square inches being equivalent to 1 square foot. All right, and same arguments for square yard is 9 square feet. These maybe are not as familiar. An acre is 43,560 square feet, or 4,840 square yards. And 1 square mile is 640 acres. And the square yard is not used, it seems like most of the time things are talked about in square feet, like the square footage of a house, the square footage of a building, the square footage of a classroom. But you do use square yards when you're talking about, I think, carpet normally, and some
carpet,
flooring.
Concrete.
Oh yeah, they buy it by the yard, yeah. So
roofing.
Okay, so square yards is used some. All right, you're going to like this first problem. Use the figure to the right to find its area in square units. Yes, all you have to do is count the squares. Is that not awesome? It is. 1, 2, 3. And you could be clever. You could multiply 3 times 5, or you can actually count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The answer is 15. Awesome. Square units. So you could put a units with a little square up top if you wanted. All right. Next question. Similar, slightly trickier. We've got a triangle, and we can see, we just have to assume that if we put these 2 together, they're going to make a complete square. All right? So we've got 1, 2, 3, 4, 5 of those. And then, let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it goes down 1 each time. So we've got an 8, and then a 7, and a 6, and then a 5, 4, 3, 2, 1. So if you're adding these up in your head, it's kind of fun to find the tens. Like 9 and 1 is 10. 8 and 2 will make 20. 7 and 3 makes 30. 6 and 4 makes 40. And then the 5 and the 5 will make 50. So that's 50 units squared again, or square units. like that. Not rocket science, but kind of fun. All right, now we're going to do just some conversions. We have a relationship between where they want to kind of let you know what a square centimeter, how it compares to a square inch, and so they give you this conversion that 1 inch squared is equal to 6.5 centimeters squared. So if we want to convert 11 centimeters to inches squared, we'll use our unit multiplier technique. We have 11 centimeters squared over 1. We're going to multiply that by the unit multiplier. We want to get inches squared, and we need to cancel centimeters squared, so we're going to put that on the bottom. And then you just put what the ratio is. They tell you that 1 inch squared is 6.5 centimeters squared. Okay? And so to calculate this, you'll see your centimeters squared cancel. You're just going to do 11 divided by 6.5, which is 1.69 inches squared rounded to the nearest hundredth. So 27 meters squared is how many yards squared? Well, looking at your table, here's your relationship. 0.8 of a meter squared is about 1 yard squared. So we'll set the unit multiplier up. 27 meters squared over 1. We want to cancel our meters squared, and we want to end up with yards squared. So we're going to put the 0.8 with the meter squared, and we put the 1 with the yard squared. Notice that your meters squared cancel. You have yard squared on top, so that's going to be 27 divided by 0.8, which is 35.44. Or not. Did I calculate it wrong? So, yeah, 27 divided by 0.8 equals. How about that? Is that better? 33.75 yards squared. Sorry, I must have typed something wrong. Okay, now in section 9.1 we saw that in most other countries the system of measurement that is used is the metric system. In the metric system, the square centimeter is used instead of the square inch. And the square meter actually replaces both the square foot and the square yard. So we use square meter. We don't have another unit. The English system uses the acre and the square mile to measure large land areas. The metric system uses the hectare. I swear I've heard hectacre, but I guess it's hectare is what they're saying. The hectare is about the area of 2 football fields placed side by side. Okay, approximately 2.5 acres. 1 square mile of land consists of approximately 260 hectares. Just as the hectare replaces the acre, the square kilometer is used instead of the square mile. 1 square kilometer is approximately 0.38 of a square mile. So in my mind, I'm thinking 40% of a square mile is a square kilometer. You know, cut it in half and then take a little bit off of that. Some basic conversions for the units of area are given in the table. So we have for what a square inch is, a square foot and a square yard. Notice they're both in square meters. A square mile, and then an acre compared to a hectare. And it's a HA. HA is the abbreviation for it. What was I going to say? Oh, it says in the book that it was like in the 60s or 70s that Congress actually tried to make us all go metric, but in good form, the southern states said, we're not going to do what you tell us to do, and so it just turned out to be optional. Like it was like optional, encouraged for people to go metric, which means that we didn't.
Nobody did.
But I think we know a little bit more metric now because most medicines and most of the whole medical system is in metric system. And, you know, there's all our liters and our Coke bottles and that sort of thing that are in our metric. Okay, it says number 9, select from square centimeters, square meters, or square kilometers to determine the best unit of measure to express the area of a ceiling tile.
square centimeters?
Well, square centimeters are pretty tall. It's pretty tiny, you know. And a ceiling tile, if you're looking at it, we probably would like to talk about it in square feet. But according to the metric system, the square meter replaces both the square foot and the square yard. So I think we're going to need to go with square meter. Is everybody okay with that? So I can sort of see an argument for square centimeter if you have one of those beautiful ceilings with tiny little squares on it or something, you know, little tiles. But I'm going to go with square meter because I did this already and that was the answer. All right. Now it says, select the best estimate for the measure of the area of the floor in your classroom. Anybody have a guess?
Second one.
Yeah, 100 meters squared is a good measurement. If you thought this classroom is actually pretty big, but 10 meters is a little more than 10 yards, so 10 by 10 sounds good. Obviously, square kilometers is very large, and square centimeters is not very big at all. Okay, so we also have this concept. We have this concept of measuring area, which we looked at. Now we have another concept, which is measuring volume. A shoebox and a basketball are examples of three-dimensional figures. Volume refers to the amount of space occupied by such figures. And in order to measure this space, we begin by selecting some sort of cubic unit. And here's a cubic unit, which is a cubic inch. And so it's a 1 by 1 by 1 inch, and so it's an inch cubed. And here's a cubic centimeter. So again, when you're calculating volume, you kind of imagine filling it with these cubic shapes, filling it all up, and then counting the total of them, and that's going to be what you have. Common units of measurement, those are common units for measurement. Okay, the edges of the cue ball have the same length. Other cubic units measured include a cubic foot and a cubic meter. One way to measure the volume of a solid is to calculate the number of cubic units contained in its interior. Other ways, you can actually also use calculus to calculate the volume of a figure. And it's kind of interesting because calculus, the interval has to do with just adding up things or summing things. And if you find the areas and then you sum up areas, that's over a distance, that's going to be volume. Like if you think of a roll of pennies and each penny is like the area, and then you put them on top of each other and you add them all up, that's going to be the volume. Does that make sense? So that's another way to compute volume. Okay, figure to the right, yes. Now we get to count blocks. That's going to be fun. 1, 2, 3, 4, 5, 6. 2 rows of 6 making 12 cubic units. Okay. Now, another thing that we like to do with volume, we actually got a question, every now and then we get a question in the math department that we get to solve, and someone had, I guess, a sort of it was like a cone, or it was a square-based deer feeder thing, so it's like, you know, has sides like this, and they were wondering what the volume was. And so it was actually kind of a fun little math problem. I guess they built it, and so he didn't know what the volume was, so he needed to know how much, I guess, deer food to buy. So we helped him with that question.
How many 50-pound bags of feed will take?
Yeah, how much does he need? So the measure of volume also includes an amount of fluid that a dimension can hold. That is often called the object's capacity. For example, we often refer to the capacity in gallons of a gas tank. A cubic yard has a capacity of about 200 gallons, and a cubic foot has a capacity of about 7.48 gallons. So these are kind of awkward conversions, but that's what the English system gives us, this sort of weird stuff. All right, I'll take a picture of this and stick it on my on the website if I remember. In my office, I have, if any of you guys have little babies that, well, 3rd grade or so, they're taking the TAKS test, and they have to normally do the gallon guy or the gallon gal. But Becky made a gallon gal, and she's got like a little head, and then like each of her arms is a quart. Wait, yeah, she's a quart. This is the gallon, and then so she's got 4 quarts make up the gallon, and she's got some fingers too. Each everybody's got 2 fingers because we got to get 2 pints in 1 quart. And then you can see that obviously there must be, if there's 2 on each of these, 1, 2, 3, 4, 5, 6, 7, 8 pints would make a gallon. You've seen gallon? I'll take a picture. Anyway, you don't have to memorize them. I'll give it to you. But those are our little relationships. It seems like this one, if you do a lot of cooking, 1 cup equals 8 ounces. That seems to come up a lot, so you might want, because it's like, 6 ounces or 12 ounces or 8 ounces. So it's good to know. And then our capacity in the English system, a cubic yard is about 200 gallons, a cubic foot is 7.48 gallons, and 231 cubic inches is about 1 gallon. And I am certain that I have seen a Trivial Pursuit question asking how many cubic inches are in a gallon. So now you know. 231 cubic inches is 1 gallon. A gross. How many is in a gross? Y'all know that one? Another useful bit of information is, or useless, is 144 is in a gross. So,
well, and if anybody works for a factory,
they still do things in gross.
They use it in gross.
All right. Use the table along with dimensional analysis to convert the given unit to the indicated unit. All right. We want to convert 4,000 cubic feet to gallons. So 40,000. 40,000 cubic feet. Put that over 1, and we want to get gallons. Okay, so that means we want our feet to cancel, and we want to end up with gallons. And so we're going to use this one, that 1 cubic foot is about 7.48 gallons. So I will come here, and I'll put 7.48 in for gallons and 1 for cubic feet. So I'm just going to multiply 40,000 by 7.48. And you get 299,200 gallons. In the paper they're talking about there's just a lot of homes available and a lot of foreclosures. So maybe you get a home and it has a swimming pool. The first thing you're going to need to figure out, if it's foreclosed, you won't have gotten to talk to the previous owners. You're going to have to figure out how many gallons, what the capacity of that swimming pool is, so that you can make the chemicals calculate. Put the chlorine and stuff in at the right level. And so the easiest way to do that probably would be to measure the length and the width, and then just to go down, depending on how deep it is. Most pools probably on average about 8 feet if you go down, and you can do a calculation. But this is a lot of gallons. A home pool you can expect to be between 20 and 40,000 gallons. So 290. If that's a pool, that's a big one. You're going to be spending some cash on chlorine. Okay. Use the table along with dimensional analysis to convert the given unit to the indicated unit. So now we've got 32 cubic yards, and we want to convert that to gallons. So we go up to our little thing. 1 cubic yard is about 200 gallons. So 200 gallons, 1 yard cubed. Notice how your units are going to cancel, and 32 times 200 is 6,400 gallons. Okay, now a swimming pool has a volume of 48,405 cubic feet. How many gallons of water does the pool hold? Well, obviously, that's kind of like what I was saying. 48,405 feet cubed over 1. Your unit multiplier that you're going to use there is the gallons to feet, which was 7.48. So we'll just multiply the 48,405 times 7.48. And we get 362,069 gallons. So that's a big pool.
It's an Olympic pool.
Yeah. It's like that one at the Y or something. Okay.
One over there in the math lab.
Oh yeah, that one that we have. I don't know how big that one is. As as we have come to expect, things are simpler when the metric system is used. To measure capacity, the base unit that we use in the metric system is the liter, symbolized by just the L. And we use the liter. We're familiar with the liter for Coke bottles and stuff, 2 liters, 3 liters. A liter is slightly larger than a quart. A quart is about, or 1.0567 quarts is about 1 liter, so just a little bit bigger. And we have our kilo, hecto, deca, deci, centi, milli. And this is that King Henry died by drinking. This is the by, which is your base. So it could be liters or meters or grams, just different things. Drink chocolate milk. Okay, so that's your relationship in the different symbols for the liter. And they give us a couple, because I think part of the idea of the class would be for you to have some sort of sense of what these things are. So the average cup of coffee, which this is probably a little bigger than the average cup of coffee, is 250 milliliters. A 12-ounce can of soda, that's probably more like what this is 355 milliliters. A quart of fruit juice is 0.95 liters. A gallon of milk is 3.78 liters. So a 3-liter bottle is less than a gallon, right? It seems more though, doesn't it? It seems bigger. Maybe it's just all the sugar. All right, the average gas capacity of a car, they're saying is about 18.5 gallons or 70 liters. And I just don't, every car I've ever owned has only been about 16 gallons. So I guess to find the average, they must have taken some of those big like SUVs and stuff. Minivans, they have higher gallon, I guess. This is one thing that's funny when you go to other countries is that they charge gas by the liter. So you think you're getting such a good deal because it's only like $1 or whatever, but the truth is it's really expensive. Okay, and this is really a wonderful thing about capacity in the metric system. The little cubic centimeter is exactly 1 milliliter. There's no weird 7.48 gallons or anything like that. 1 decimeter, which is 1,000 cubic centimeters, is 1 liter. So you have this volume measurement and this capacity measurement that's very easy. 1,000 cubic centimeters is 1 liter, and 1 cubic meter is 1 kiloliter. So again, just kind of a nice relationship. And then I put this Blitzer bonus on here because I thought it was cool. And 1 cubic centimeter is 1 milliliter, all right? Dosage of medicines are measured using cubic centimeters or milliliters, as they are also called. In the United States, the cc, rather than the cubic centimeter, denotes cubic, rather than the cm cube, denotes cubic centimeters, and obviously you can see why, the cc. When taking medicine by mouth, such as cough syrup, there's an easy conversion between the English and metric systems. 1 teaspoon is about 5 cc's. So just a little bit of information. Okay, so let me go back to this one, and it says, use a table along with dimensional analysis to convert the given unit to the indicated unit. So we have 32,000 cubic centimeters, and we want to go to liters. So we go over here and we see that 1,000 cubic centimeters is 1 liter. So if we want to get to liters, we need 1,000 cubic centimeters. So notice how I'm putting it on the bottom there, so I'm going to cancel. And when you divide by powers of 10, we can actually just cancel these 3 zeros with these 3, and so we get 32 liters. All right, that's fun. Now we're going to move on. I should have had a little break in your notes, but I don't, so here it is. We're going to talk now about this concept of weight, and we're just on the Earth, okay? And we could make a big argument because weight is kind of related to the pull of gravity on your mass, and it does depend. Like the good way to lose weight is to go to the moon. You lose a lot of weight that way because the pull of gravity is not as fast. The other thing that you can do is convert your weight to kilograms. That's going to make you weigh a smaller number as well. And there is an English method that they don't even have on here, and I guess I should Google it, but Somebody's got their phone out. They can Google this for me. I'll give you something to do. Find out how many pounds is a stone. How many pounds is a stone? Because in my family, my mother's family is Australian, and in Australia, they talk about stones in terms of your weight. And so I think it's around 8 pounds. Because if you lose a stone, like, when you're talking about weight loss, I lost a stone, that's actually a good thing. You lost 8 pounds, or half a stone, or I can't remember. Or is it 16 pounds? Anybody, so we'll be waiting to hear what that result is. How many pounds is a stone? Okay, but that's actually an English unit that's just not used very often. All right, and now there are 16 ounces in 1 pound, and there are 2,000 pounds in a ton. Okay. So use the given equivalents along with dimensional analysis to convert the given unit to the indicated. So 35 ounces over 1, we need to get to pounds. So we want pounds on top and ounces on the bottom. And we know that there are 16 ounces in 1 pound. So we will divide 35 by 16. And it's 2.1875. I don't know what the rounding is.
It's 14 pounds per stone.
Is it 14 pounds? Okay, thank you. 2.19 pounds. I guess the conversation I remember having with my aunt was, because I had lost a little weight, and I guess she did say, oh, you've lost about half a stone, so I guess I had lost 7 pounds. All right, so what did we say? How many? 14 pounds is equal to 1 stone. Another bit of useless information. Okay. Actually, it might be really cool. The basic metric unit of weight is the gram, used for very small objects such as a coin, a candy bar, a teaspoon of salt, a line of cocaine. All right, a nickel. I'm going to go into this whole kilo and gram discussion here because I don't know. I thought it might make you keep your attention. A nickel has a weight of about 5 grams. As with meters, prefixes are used to denote a multiple or a part of a gram. Table 9.8 applies the common metric prefix to the gram. The first part of the symbol indicates the prefix, and the second part indicates the gram. Okay, so again, here's your base. Here's my King Henry died, and there's my base, which is to buy drinking chocolate milk. So the gram is just the same. 1,000 grams is a kilo, 100 grams is a hectogram, 10 grams is a decagram. And then this is kind of a nice, because we are trying to get you a sense of the unit of the metric system. A paper clip weighs about 1 gram, and it's about 1 millimeter thick at the tip there and 1 centimeter wide. So there's some little measurement, or little ideas for you. Okay, so if we have 760 milligrams and we want to convert that to grams, while we can use our dimensional analysis, I like to use the little mnemonic, King Henry died by drinking chocolate milk. The base here is the gram. Now we want to go from milligrams to grams. So you start to the right of the letter that you're at, and you go to the right of the letter where you want to be. So I want to go to the grams, so I'm going to go 1, 2, 3 units to the left. So I'm going to take my 760, and I'm going to move it 1, 2, 3 units to the left. So it's 0.760 grams. Make sense? Okay. If we want to convert grams to centigrams, we could still use our King Henry died thing. And we are at our base now. We're at the base. We're at grams. And we want to get to the CGs. So we go to the right of where we're at, and then we move 2 places to the right to get to the centigrams. So the 8, the decimal is understood to be right after the 8, and so we'll just move it 2 places to the right, and we will get 800 centigrams. All right, so this is the question I had some jokes about before. Say you find 32.6 kilos of Coke, right? And I don't know, but I'm assuming that do you sell it by the gram if you're going to sell it out in the
On the street.
out on the street. I mean people don't buy would you buy a kilo for personal use? That would be like your whole life. So let's get a feel for how many grams you have, and then I don't know what the going price is. We could probably Google that too, but I'm not going to do it on one of these computers. And then we can find out how much money you could make if you were to happen upon 32.6 kilos of cocaine. And the best part of this is if you're going to go ahead and go with this business plan, you don't even have to worry about the whole chapter on taxes because I don't think you need to be talking about what you're doing. All right, so a kilo to a gram. So KHDBDCM. Okay, so we're at the kilo, and we want to get to the gram, which is your base. So you're going to go 1, 2, 3 places to the right. So 32.6 kilograms is 1, 2, 3 places to the right, 3,600 grams, 32,600 grams. I was getting excited. 32,600 grams. So if it were like, it's probably, what is it? You think it's $10 a gram or $100 a gram?
80 to 100.
80 to 100? Did you look it up?
Yeah.
You go. All right, so 80 to, let's say it's 100 because that'll make it easy. All I have to do.
Then talk about how if it's pure or not. If it's pure, you're going to have to cut it.
Yeah.
Okay, well, but that would be the person's problem, or is that the dealer's problem, or?
That was definitely a dealer's problem.
Okay. All right, so they have to add. Well, that's actually a good thing if you have to cut it because
That's
you
right.
have even more.
Then you have to load it down.
Oh, that's a good thing. Now, okay. So anyway, let's say it's all ready to distribute. So it's 32,600. It's $80 to $100 a gram. So you put 2 zeros right there, and if you were to find 32.6 kilograms of cocaine, you could sell it on the street and make $3,260,000. Right?
How many kilos?
32.6.
Well, it says also that a kilo can go anywhere from 12 to 35,000.
Oh, for 1 kilo?
1 kilo, yeah.
Yeah.
Wow.
See, that's like I said, that's pure though.
Yeah.
Well, yeah, that's a lot of money.
But then you gotta cut it.
Yeah, there's all
Cut
that
it and
work
bag it.
involved, and then you have to keep those people from chasing you down trying to get you. All right.
You're actually doubling it once you cut
And
it.
then the government
Yep.
is all on your back. Okay. All right, it's a bummer. Anyway, it's a fun little. It's what's good about it is that it really does get you thinking about converting between in the metric system.
750.
Pardon?
The highest price for a gram was in New Zealand at $7.50.
Oh, okay. What you found it by state, like if you
Yeah, it just broke it down kind of.
by location. Okay, that's so odd. All right. In the metric, you can find anything on the internet. In the metric system, the kilogram is a comparable unit to the pound in the English system. A weight of 1 kilogram is approximately 2.2 pounds. So that is something else you have to think about. Are you going to be able to lift all of these kilos? Thus, an average man has a weight of about 75 kilograms, which immediately I'm saying, what's average? Well, if you do 75 times 2.2 is 165, they're saying is the average weight for a man. Objects that we measure in pounds are measured in kilograms in most countries. And they say the average weight for a woman is 140 pounds. I have heard that. So if you do 140 and you divide by 2.2, now you only weigh 63, which is so much nicer. But it's 63 kilograms. Okay. So number 16 should be, and it is. I think I get the right answer on number 16. Number 17, when I was making these problems, I just cut and pasted. They had little charts each time. I didn't cut the chart. And they're actually rounding. They're doing it a little bit differently, and so there's a rounding. You just want to use the chart and don't use what I gave you right here. The 1 kilogram is approximately 2.2 pounds. Because there's some rounding occurring there. Errors, I'll show you in a second. All right, so if you have 540 pounds and you want to get to kilograms, you take 540 pounds, put that over 1, and then you're going to multiply that. The kilograms is what you want to end up with, so you're going to cancel the pounds. So there's 2.2 pounds in 1 kilogram. 1 kilogram. Okay, so 540 divided by 2.2 equals, yeah, so this is an example of where I get 245. Okay, but that's not the answer on the online homework. The answer on the online homework is 243. And the reason is because if you go to the, this is the actual homework problems. They give you this little chart right here, and they tell you that 1 pound is approximately 0.45 kilograms. So they went the other way, and which means if you use our thing to get from one pound, if you want to figure out what 1 pound is, you have to do 2.2, 1 divided by 2.2 to get pounds in terms of kilograms. And if you do 1 divided by 2.2, you get a repeating decimal. And see, they truncated it, or they just stopped it at the 100th. But by doing that, there's some error that's being incurred, and that's where that error is. Okay. So in order to get the right answers that are on the test, on the online homework, you're going to want to use their little chart. So I'm sorry about that, and I will write the publisher because it's kind of inappropriate that in the textbook, because I got this stuff from the textbook, they talk about the 2.2, but then in the homework they have a chart that it's just different rounding, but it's weird.
Yeah, well, it makes a big difference though.
Well, yeah, that is something that we're not even really talking about, but when you have rounding error can be significant. Yeah. Okay. So, but the truth is that even this 2.2 is probably an approximation. It is just an approximation to a kilogram. Okay, so there's a little chart on the online homework that tells us that 1 pound is equal to 0.45 kilograms, and that's the one that I would prefer that you use. So I'm going to erase this, and I'm going to say 540 pounds over 1. We want to get to kilograms, so we'll put the kilograms here and the pounds here, and we've got 0.45 kilograms over 1. Now all we have to do is multiply 540 times 0.45, and we get 243, which is the answer that they got, 243 kilograms. And then to do number 17, you have 580 kilograms over 1, and we'll use the same chart. We want to get that to pounds, so we'll put the pounds here, and we'll put the kilograms down here, and so we'll put a 0.45 here. So we'll do 580 divided by 0.45, which is 1,288.89 pounds. Okay, so and this last little bit is I just wanted to kind of talk to you about this. We have seen a convenient relationship in the metric system between volume and capacity, and that is that 1,000 cubic centimeters is 1 liter. That's very nice. This relationship can be extended to include weight based on the following. 1 kilogram of water has a volume of 1 liter. And so you can get that 1 kilogram is equal to 1,000 cubic centimeters. So here's a relationship between volume and the weight of water. You have 1 cubic centimeter of water is just going to weigh 1 gram. 1,000 cubic centimeters, or 1 liter of water, is 1 kilogram, and 1 cubic meter is equal to 1 kiloliter, or 1,000 grams, or 1. That's a ton or a bunch. It's a lot. I forgot what the word was in metric. I don't know that they call it a ton. Did they?
Deciliter?
Well, the big T, I've forgotten. But anyway, it's 1,000 kilograms. I didn't write it down. It's like a ton. I didn't put it down. Now, this relationship is not nearly as nice in the English system. In the English system, 1 cubic foot of water weighs 62.5 pounds. So it's real hassle. I mean, I can remember in calculus classes, you're often worried about volume and the rate that something's like draining, and if it's water and how much water you have maybe pushing, what's the force of the water pushing against the dam and all this stuff. And you have to know if depending on the units, if you want to find the weight, then you're going to have to remember that it's 62.5 pounds is the weight on a cubic foot of water. So that you can run into trouble where it's just so nice in the metric system that you have this idea of 1 liter of water is 1 kilogram of weight. Okay, so that's it for the section 9.2 and 9.3.